How are age-adjusted death rates calculated? Have you ever wondered how experts compare death rates across different populations? It all comes down to a method called age-adjusted death rates. This technique helps us understand mortality rates without the confusion of varying age distributions. Let's break down how this calculation works step by step. First, we need to calculate age-specific death rates. This means for each age group, we take the number of deaths and divide it by the total population size of that age group. This gives us a clear death rate for each age segment, usually expressed per 1,000 or 100,000 people. Next, we choose a standard population to use as a reference point. A common choice is the United States 2000 standard population. This standard helps ensure that we are comparing apples to apples when looking at different populations. After that, we apply the age-specific rates to our standard population. We multiply each age-specific death rate by the number of people in that same age group of the standard population. This step helps us calculate how many deaths we would expect in the standard population if it had the same death rates as the population we are studying. Once we have those expected deaths, we sum them up across all age groups. This gives us the total expected deaths in our standard population based on the death rates we calculated earlier. Finally, we calculate the age-adjusted death rate. We take the total expected deaths and divide it by the total size of the standard population. To make it easier to understand, we multiply by a constant, like 100,000, to express the rate per that number of people. This method is known as the direct method of age adjustment. It provides a summary death rate that reflects what the overall death rate would be if the population had the age distribution of the standard population. In the context of demographic data in the United States, age-adjusted death rates are incredibly useful. They allow us to compare death rates across different states, racial or ethnic groups, or even over time without the bias of differing age structures. For instance, older populations tend to have higher crude death rates. By adjusting for age, we can see if a higher death rate is due to age alone or other factors at play. Understanding how age-adjusted death rates are calculated helps us make sense of mortality risks across diverse populations. It gives us a clearer picture of health trends and helps inform public health decisions.